Welcome to this video on graphing exponential functions with transformations. By the end of this video, you should be able to graph an exponential function using Desmos and identify the domain, range, asymptote, y-intercept, x-intercept, and transformations of an exponential function. And I'm going to do the first couple with you to get you started, and then you'll finish the rest of these. Okay, our first graph is f of x equals 2 to the x. That is our parent graph, so here's what it looks like in Desmos. Okay, and we're going to use this to graph on our, make a sketch on our paper. What we really need is the x-intercept and the y-intercept and the asymptote. So our y-intercept is at 0, 1. So I'm going to put it here at 0, 1. Well, looking at the equation, there's no plus or minus off of there, so that means my asymptote is here at 0, which means there's no x-intercept. Okay. And so, just to remind you, we're starting low here on the left, writing along 0, and then we're going to go through the y-intercept and up after that. So we're going to just sketch our graph in just like that. Okay, so we sketched it. So for your sketching, what you really need is the asymptote, the x-intercept, if there is one, and the y-intercept. And then make sure whether you're growing or decaying, depending on the equation. The table of values, we're not going to really worry about the table of values, so we just ignore those. So our y-intercept, we said, was there at 0, 1. Our x-intercept, well, the x-axis is the asymptote, so there's not going to be an x-intercept. Transformations, there's nothing happening in the exponent, there's nothing added or subtracted off the end of this equation, so it's going to be no transformations. Our asymptote is at y equals 0. Our range, so we're always looking for our range. How does your y values compare to your asymptote? So our graph is above our asymptote, so all of our y values are greater than the asymptote. And then the domain, it's never ending to the left and never ending to the right. So our domain is all real numbers. Okay, let's go ahead and try the second one too. So here's our second graph, f of x equals 1/3 raised to the x. So we get this decay problem, and if you notice, our b value here is less than 1, and that's why it's between 0 and 1, and that's what makes it a decay. Our y-intercept is at 0, 1, so I'm going to go and put my y-intercept on my graph at 0, 1. Looking at the equation, and when we're looking at the graph, there's nothing adding or subtracting off the end of this equation, so this is our asymptote. And that means we're not going to have an x-intercept either when we get to that. So this was a decay, which means it started up higher, comes through the y-axis, and rides along the asymptote. So there's our sketch. Don't worry about the table. So our y-intercept was at 0, 1. There is no x-intercept because the asymptote is the x-axis, so we're going to say there isn't one. There's no left or right transformations. So looking, there's no transformation left and right in our exponent. There's nothing added or subtracted off the ends. So this one has no transformations. But you can see the other equations will have some transformations, so pay attention to those. Nothing added or subtracted, so that means our asymptote is at 0. Now how does our y values compare to your asymptote? They're above the asymptote, that makes it greater than. And then your domain, it never stops left and it never stops right. So it's all real numbers. Hopefully that was helpful. Let me know if you have any questions. See you in class.